Digital twin is perhaps the most important development in computer-aided design since digital rendering. It's more than a way to digitally represent products and the processes that make them. It's a parallel engineering world, a place where what-if scenarios and experiments can be performed to optimize designs and processes. Digital twin is not only a tool that speeds development in engineering, but it's also a vital element in engineering risk management, a way to try things that would be unthinkable in the physical world, with the possibility of a high-value payoff. Artificial intelligence can offer similar benefits to engineering processes and is already a critical tool to aid in decision-making. So what happens at the confluence of these two important technologies? I had a very interesting conversation with three experts in this field. Take a look.
One of the best ways to look at where to start with digital twins is look at what use cases have the biggest business impact and where do you have technical readiness. So where do we already have existing models that we can synchronize with additional data that we can embed in a flow or a workflow. So technical readiness is a key aspect in choosing the low-hanging fruit, but make sure that you're also doing things that drive business value. Especially those first initial projects, it's really important that you show value and why it matters to organizations. So if you just choose something that's really easy to do but doesn't have a really big impact, that's nice to have. Where if you have something that's got a significant business impact, but also we have the technical readiness, we understand the models, and that's also where we're heading, with more intelligent twins, where in the past we had just a meta model, a data model of the physical, and we kind of synchronize it, and now we have a bigger meta model, where having that engineering knowledge and having models that describe some of the physics and attributes of those, bringing those into the twin and making it part is where we're also seeing the future of digital twins heading.
I'd like to add something real quick. Peter mentioned two things just kind of offhand, but they're very, very important. One of them is model-based, and we call it MBSE a lot of times, model-based systems engineering, which is a new approach to design where everybody gets to have a say and everybody gets to see what's going on with the end product as it's being developed. Very, very interesting. And I was just talking to a very large aerospace and defense contractor just the other day. They're using that, and it's a fairly simple transition to get to digital twins if you're doing MBSE. But then he also mentioned composability. Composability is a really important and really great feature, to your point about where do you start, because a composable twin, you can start small. So you can start on a plant floor, for example, you start modeling a motor, and then you model a gearbox, and then you mate them together, and now you've got that motor gearbox combination, and then you put that in a digital twin of a robot, and now you've got that whole digital twin of the robot. And so you're starting to build up, and as you build that up, you get more and more value out of that digital twin, because then you've got a digital twin of the robot. Now you can do predictive maintenance, really interesting things on it. And then you add maybe a conveyor, and now you've got a digital twin of that particular work cell. Then you can start doing more stuff, important stuff, and you start to see the value start to build as you start to layer in these things. So you don't have to start with this giant digital twin of everything. You can start small, build your way up, because then once you got that work cell, then you've got your production line, and then you got multiple production lines, and you can then build a complete digital twin of your factory and your organization. And so you're going up and up and up, and now you're making business decisions using digital twins of everything you have, and you can start really, really small.
Yeah, I mean, so Native Edge is designed specifically for that. So it can manage and orchestrate one single factory if that's what you would like. And it can be, the orchestrator can be located right there in that air-gapped environment and control hundreds, if not thousands of machines on that one factory floor. But you can also have a master orchestrator that manages and orchestrates globally all of your software. So the idea of being able to scale from a distributed manufacturing perspective has been thought of when this came around. So it's definitely something that we do.